for joining my session on securing Kubernetes. Or well, at least taking some of the scissors away from your developers so that they don't actually go and harm themselves. Actually, I probably should have made the title so that it's safer, at least. I'm not sure if there's a thing which we actually can make a truly and 100% safe. Especially thinking about the announcements made yesterday about another set of CPU-level attacks. These fancy named Zombieland attack and these different types of MDS attacks like Riddle and Fallout. It actually sort of, I read about a bit of those this morning through Twitter, and I really got thinking of just ditch the computers and start making my life a lot simpler. Reading about those type of attacks and Meltdown and Spectre, which we had last year, it truly feels that the world is not a secure place anymore. Well, let's just put that aside and actually start to focus on Kubernetes. So my name is Jussi, and from the accent you'll recognize that I'm not from UK. I'm actually from Finland. I work as a developer/advocate at Quota EU, where we've been focusing for the last year and a half on building a Kubernetes distribution. And I've been actually working with containers and microservices for the last 5 or so years. I went to production with Docker 0.6 version, which was a really, really bad idea back then. But luckily things are a lot more stable nowadays. You'll find me on all around the internet using the handle Jussi Nummelin if you want to follow me or tweet at me or something. So in the keynote this morning, Dave Farley said nicely that you really need to release often to be actually learning how to do it properly. So if you think about DevOps, one of the kind of essential things in the whole DevOps thinking is to release often so that you're able to go faster than your competition. You're able to probably break things more, but you're also able to fix things more and more rapidly. And that makes you able to adapt things, to adapt the ecosystem, what's happening, to adapt with new technologies, take new things into use, and so on. And as we've probably all seen, containers and now Kubernetes is one of the great tools to actually help you do that. And sort of one of the key motivation in building Kubernetes and actually even building the predecessors of Kubernetes inside Google, Borg, and these other systems, Omegas. Joe Beda, actually, who's the founder of Kubernetes project, said in some conference, can't remember where it was, but the key motivation of building those sort of systems is to actually enable sort of self-service platform for your developers and your operational people. And having something as a self-service means that it has to be secure enough so that people don't actually easily break things. So that's the topic for today. I'm going to sort of show a couple of things. What are those scissors and what I mean by having scissors around everywhere. We'll talk a bit on security in cluster kernel, a bit on role-based access controls, what are the pains and gains on it. We'll talk a bit on how to actually enforce that the workloads are safe or safer than by default. And then we'll talk a bit on the problem of hoarding. As the abstract of the talk mentioned, this talk is actually sort of inspired by Liz Rice's talk on last year on KubeCon, where Liz sort of shows that why it's actually dangerous to run with scissors. And she nicely showcases and demonstrates a couple of things on Kubernetes and on containers, why they are not really safe. I really highly recommend to look up that talk on YouTube. There's actually a small link on the slides too. It's around 20 minutes talk, so it's not that long. So probably we've all been hearing a lot when we've been kids, and now whoever has kids probably has been telling the same thing for your own kids that really don't run with scissors. You'll probably go and hurt yourself. If you're a super lucky guy like we're now here, you might be able to run with scissors like miles and miles and miles, and nothing bad happens for you. But if you're like me, a truly unlucky guy, I'll probably stumble in the first 20 meters or so and hurt myself badly. So what it means that you might be safe, you might not be safe. It really, all of these things depend on your use case, how you're using the tools and so forth. Who's actually been setting up your own Kubernetes clusters? I mean, really setting them up and not just pushing a button on Google or Amazon. Any hands? Okay, quite a few hands. So you've seen that there's quite a few knobs to turn on the different settings. If you actually look on the different components of Kubernetes and the options they give, for example, the API server, which is one of the most crucial and critical components, of course, in the cluster, it has 162 different flags to configure. I have to actually look at the numbers. I don't remember them by heart. Cubelet, which is the agent sitting on the nodes, 185 config options. And that's just two components. In a typical Kubernetes cluster, there's like 10, 15 different sort of system-level components existing. Plus whatever add-ons, crucial add-ons like DNS, autoscalers, different components you run on a cluster, another 100 knobs to turn, another 100 knobs to turn. There's been a lot of examples, well, kind of good examples of things misconfigured, but of course from security point of view, super bad examples of people running wide open clusters on internet. I think Tesla is one of the sort of most famous examples. So the Tesla Kubernetes cluster was actually open and people were able to inject crypto miners in Tesla's clusters. Nice. One of the sort of problems with the whole container thinking is the root versus nonroute users. There's been actually a study conducted by MicroBadger team in, I think it was last year. 86% of the images on Docker Hub are configured and built so that it's actually using root to run whatever is in the image. And unfortunately, root is still root even though you run things on containers. And unfortunately, the user namespace capabilities are not available on Kubernetes cluster. There was a plan to get them supported on Kubernetes on 1.14 release, which came like a month ago. Didn't make it. I am trying to follow the discussion and activities around that on Kubernetes, and to be honest, it doesn't really look too good to go in 1.15 either. So I wouldn't be holding my breath to get user namespace support in Kubernetes anytime soon, unfortunately. The root versus non-root thing it's sort of a black and white thing, whether you can do things or you cannot do things. Luckily, the folks working on Linux kernel came up with a concept called capabilities. So it's sort of a functionality or concept to bring sort of shades of gray in between black and white. It came in, it's been around for quite a while. It came in kernel 2.2, I think. There's about 40 different capabilities you can configure for any given process. And of course, with containers and Kubernetes, you can think container as a sort of process. Well, it is a contained process. The problem in containers, in container engines, and therefore in Kubernetes also is the fact that there's so many capabilities on by default. And then if you run with privilege true, well, you have all the capabilities. And then you have 86% of all the images running as root. So you have root and all the capabilities, so it's a super bad idea. Of course, there are use cases where you have to really do that, but you should really think about it and not just do it blindly. So, just as an example, and in the talk I mentioned from Liz Rice, she actually showcases this on live. So I made just a small Docker image based on the standard Nginx. Just added a libcap package so that I can actually have some tool which I'm able to use to get all the capabilities that I have. Push that as a default simple pod to my Kubernetes cluster, exec myself into the pod to see what capabilities I have, and voila, I have like 2 full rows of different capabilities. And who am I? I'm root. Doesn't sound like a good idea to me. So what it essentially really means is that the pods, your containers that you're running on your cluster, they're just not safe by default. Really, really far from it. And actually, if you think about Kubernetes as a whole, with all the different knobs to turn, all the different default settings you have, I'm sort of brave enough to say that Kubernetes is not safe by default. Far from it. So you really have to think about how to make it more secure. You really have to learn how it actually works, how it builds, and so forth. Okay, so there's scissors. Let's start to think about ways to actually take the scissors away from your operations and development for folks. So, of course, the most important thing you have to start with is to make the cluster kernel secure. And by cluster kernel, what I mean is the actual Kubernetes components sort of running your cluster. API server, Cubelet, the different controllers, and different components you have controlling the cluster. Lucky for us, there are actually tools to help you make your clusters more secure. So this is the Center for Internet Security. They've released and they maintain a Kubernetes benchmark documentation, which basically has a long list of items to check. Do you have this flag on? What it means, why it's not secure to use that flag, and how to mitigate it. And lucky for us, there are actually automated tools to help you with that. For example, the folks at Aqua Security, they have this tool called KubeBench, which is super nice. Just run it on your cluster, and it'll report what things you should be go and fix. And what it actually essentially means is that you should really lock your doors into your cluster. And I mean every single door. There's not just one door in Kubernetes cluster, unfortunately. There's a lot of doors. And one of the sort of not really a problem, but a thing which quite often gets not that much attention is the complexity of the authentication in Kubernetes. So there's a lot of different ways to authenticate users, and whoever is talking with the Kubernetes API, there's a lot of different ways to configure it, and what it means, of course, is there's a lot of different ways to how to configure it poorly, unfortunately. So that's really one of the key things to watch out in your cluster. As you probably all know, most of the components in Kubernetes, they talk with each other through TLS, which is of course a good thing. But configuring TLS is, well, pain in the behind, to put it nicely. One of the sort of things that got me or kind of surprised me is the fact that the kubelet running on each of the nodes, by default, it actually uses a self-signed certificate. I was like, what? Why? What? How is that a good idea? So that's one of the truly specific things which you really have to be configuring and focusing on. To actually help with that, we as in folks at Container, we actually did an open source component to help with that. It's called Cubelet Rubberstamp, which helps you automatically create a cluster CA signed certificate for your kubelet. Because running a self-signed certificate on a kubelet gives you a man-in-the-middle attack vector. Because nobody is actually verifying that it's a real kubelet that I'm talking to. As I mentioned in the Tesla example, the way the attackers got in the Tesla cluster was through an API on a kubelet, which was unauthenticated. Like, okay. Which was actually on by default, still in 1.9 version of Kubernetes. I think they closed it by default on 1.10. I'm not sure, but around that time anyway. One key thing, of course, is to make things secure, but of course, you have to have clear line of log that who did what and when. And lucky for us, Kubernetes actually does have audit capabilities built in. But surprise, surprise, they're not on by default. Again. So basically, you get an audit log item for every single call to the API server. And you actually can configure it to be super fine-grained, so you can actually have a different audit log for each step that the processing takes place in the API server. So you can get super fine-grained audit logs. But you have to actually go and enable them. And of course, it means that you have to actually store them somewhere. One of the sort of cool and nice things in the audit capabilities is that you can actually configure the API server to push the audit logs into a webhook. So you can actually have a system somewhere else that just accepts these as webhooks and then store them like on Elasticsearch or something. That's pretty easy to actually pull off. But again, you have to configure TLS and everything onto that. So it might be a bit of pain, but it shouldn't be that difficult. Well, shouldn't. If you're running on cloud provider Kubernetes, like Amazon EKS or Google GKE or something else, your mileage might vary. I haven't been playing around. I've been playing around with EKS a bit, and I know that on EKS you can actually push these audit logs into a CloudWatch, which is nice. For other providers, I don't know. Just make sure that you are able to get the audit logs. If you manage your own cluster, then just learn how to configure auditing properly. All right. Let's talk a bit on role-based access control. So it's been actually on by default for quite a long time on Kubernetes, so that's a good thing. In Kubernetes, every single call to the API server is always authenticated and authorized. So with role-based access control, you can essentially configure that who can do what in your Kubernetes cluster, which is the sort of first line of defense in a way. It's super fine grained, so you can actually say that, okay, I'm Jussi, you're allowed to only create a pod in a cluster. You can do anything else. Or you're an admin, you can do whatever you want. And everything in between that. And everything, different combination you can actually think of. Everything's possible, which is a good thing. Sort of. As many other things in Kubernetes, role-based access control is also scoped, or often at least scoped to different set of namespaces. So you can actually say that, okay, I'm Jussi, I'm allowed to create a pod only in this specific namespace. That's just a couple of examples of different role-based, these RBAC rules. So what you typically configure in your RBAC rules is what API groups, what kind of objects am I allowed to work on? And also what I'm allowed to do on those verbs, on those objects. And those are defined by these verbs, whether I'm able to get, list, watch, update, delete. Like everything in Kubernetes is always expressed with these HTTP-like verbs. To actually make that rule, sort of to apply to some set of users, you have to use these role bindings. So you bind a rule to a set of users. In this example, I'm just binding it on a specific service account, actually tied into a metric server deployment. Another example is for Calico, which is a CNI networking provider. A lot more rules. And actually, those are small examples. I've seen RBAC rules which are 400 lines of YAML, which is one of the pain points. With RBAC, you actually often hit a sort of sea of YAML or wall of YAML, unfortunately. So, although it's a nice thing that we can do these super fine-grained controls, it's another 200 different knobs to turn, and it's so easy to make mistakes on RBAC rules. One of the sort of most problematic parts on this RBAC is what can I actually do? There's no API on Kubernetes, at least for now, there's no API on Kubernetes where I can actually call that okay, I'm Jussi, what can I do? Give me a list of things I can actually do. No such thing as actually exists, unfortunately. There are a couple of sort of external helper tools, like for example this RBAC manager. It makes life easier when you're working with complex RBAC rules. I'll show an example in a minute. And then there's this external tool called kubectl who can, with which you can actually ask a question that who can create a pod in a default namespace, which kind of gets you at least halfway to the question that what can I do? It helps you a lot with that. What it actually does is it sort of gets the list of different RBAC rules and role bindings and whatnot from the cluster and sort of mangles the information together to actually spit out you a list that who can do a specific thing on a specific namespace. That's a good thing. So just as an example for the RBAC manager, so it's a custom resource that you deploy into your cluster. It's more sort of self-evident about the rules than just the default RBAC way of defining things. So it might or might not make your life easier. At least check it out whether it helps you or not. All right, that's about RBAC. Complex thing, but it's there to actually help you. So you just have to learn how to use it properly. Then about actually ensuring that our workloads are running safely in the cluster. So one sort of super easy and almost sort of trivial thing to have in your pod definitions is this run as nonroute flag in the security context of a pod. So what it actually tells to Kubernetes components that whatever we run in this pod, it's not allowed to run if it tries to run as root. Essentially, when I deploy that pod into my cluster, the pod fails to create, of course, as it should, and the error says that there's a run as nonroute flag, but the image is configured to run as root. And surprise, surprise, the image I'm trying to use is a standard Nginx official image from Docker Hub, one of those in the 86% of images. You just have to remember to configure this on each and every pod you create on the cluster. Make sense? Kind of no. Of course, it would be a lot better to have all the images configured to run with non-root users. But unfortunately, in many cases, that requires a lot of effort. If you actually want to just deploy a Nginx hosting your static website, do you really want to build your own Nginx image for that? Well, if you really want to have it secure, you actually have to do it. And in many cases, it's actually a lot of effort. Of course, it's super easy on a greenfield project, on a greenfield component. Just start to design it so that it can actually run as nonroute. To actually sort of really force things to run securely, Kubernetes has this concept of a pod security policy. So it's essentially a set of rules you configure to control the security configuration of each pod created in the cluster. It's an admission controller, and admission controllers are a set of components that interact with the objects before they are actually stored on the API server. So they can actually validate things, they can even mutate things, in whatever way needed. In this case, we are focusing on the security configuration on the pods. And the nice thing with pod security policy is that it can actually set defaults on your pods. So whenever me as a lazy developer, I don't remember to put all the proper configuration in my pod YAML, the pod security policy can actually put some sensible defaults on my pods. So it really acts as a sort of enforcer. So I'm not allowed to run stupid things anymore in the cluster, which I probably would do otherwise. Again, set of YAML. There's no way of escaping YAML hell, unfortunately, with containers and Kubernetes. So typically what you configure in a pod security policy, of course it's a case by case and depending on your environment, but you really should focus on things like not allowing things to run on host network or host bit namespaces. You can add a rule that everything must run as nonroot user. You can configure how SC Linux configuration works. And you can actually go and define what type of volumes you're allowed to set up on your pods, which is super nice because that means I'm not allowed anymore to do stupid mounts from host side to my pod available on internet, which would be a super, super bad idea. I guess you're starting to see a trend. So, okay, there are nice things, but some of these are actually painful to configure. And to be honest, the pod security policy is actually one of the most difficult things to configure properly on Kubernetes cluster, if not the thing, at least in my opinion. It's actually, when you start to configure pod security policies, you define a policy that's super secure, you deploy that to your cluster, voila, nothing works anymore. No single pod can be created in your cluster, not even the system level pods. So with pod security policies, it's actually super easy to just completely cap your cluster. Yes, I've done it. Luckily not in production. Why it actually is like that is through the fact that what security policy is actually enforced, it's selected via role-based access control rules, which you saw that are not really trivial thing. So now we have two complex things and we put them together and the result is complexity plus or something. And then you really have to ask yourself a question, when was the last time you actually created a pod in your Kubernetes cluster? And by that I mean, when did you actually go and say kubectl create pod or apply a pod YAML? You really don't do it. You always create deployments or jobs or daemon sets or even something higher level. So how do we actually then, because we use RBAC to select the PSP to be enforced, and I'm not actually creating the pod. It's some controller somewhere creating the pods for me. So that's where the problem actually comes from. So what it actually means that when you have a pod security policy, you bind it through or enforce it through RBAC and with this special use verb. So I'm creating a cluster role that uses this example policy. And that rule then has to be bound to a service account via cluster role binding. And on my deployment now, I have to use this specific service account. So it's like whop, 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 whop. So you see that it's super easy to make mistakes on that. So when you're starting to use port security policies, do try them before going to production. And do really, really try them properly. We've seen a lot of problems people having with these. And that's just a simple example. The real-life examples are, of course, more and more complex. Okay. Hoarding is another sort of scissors, or at least a problem. And by hoarding, I don't mean this type of hoarding. Okay. Yeah. By hoarding, in the context of Kubernetes, I mean hogging all the resources for your applications, so that none of your team members actually have any resources left for them. Whether you do it intentionally or by accident, there's both ways are doable in Kubernetes. To mitigate that, Kubernetes has a concept called resource quota. So it's essentially a way to limit the aggregate resource consumption of your applications. And as many other and most things in Kubernetes, it's always scoped to a specific namespace. So you can say that namespace belonging to that set of applications can use only 2 gigabytes of RAM, for example. And again, it's yet another admission controller, so it's something that gets enforced on the object you create before they are actually stored on the API server. So it's really enforced. There's no way around it. What you can actually configure these quota limits on is CPU, memory, storage, if you're using volumes. And also a nice thing is that you can actually enforce limits on different object counts. So that I can set a limit that you're only allowed to create 3 pods in a namespace. Just as an example again, I create a resource quota object, and you can actually on your quota you can specify hard limits and soft limits. In this example, there's limits for CPU and memory, and you can actually as you can configure limits on your pods on both on the request side and the actual hard limits of usage, you can also configure those quotas on both requests and the hard limits. So I'm saying that okay, I can reserve only 1 gigabyte of memory, and the actual hard limit is 2 gigabytes. And with that sort of a stupid configuration of a pod, it'll mean that I can actually fit three of those pods in my namespace. You'll hear a lot more on limits and how to configure limits properly on later today, right? Yes. Another way to configure these limits is through a concept called limit range, which actually gives you a way to also put defaults in place into your pods. Because, I mean, developers are typically lazy. They forget to put things on. Well, lazy is not probably the correct word, but but at least.
No, it's a great word.
Okay. At least I forget to put things on a lot of time. Actually, as you see here, my editor is actually complaining that I don't have the limits in place, which is a good thing. But with limit range, I can actually enforce defaults also in the pods. So in the limit range, I configure that, okay, by default, every pod will have a 1 CPU limit. I create a pod without any limits configured, and essentially what's running on my cluster is a pod with specified limits. So limit range is a way to enforce at least some sensible defaults. Of course, it's a default within a namespace. So if you're running both Java and Golang apps in the same namespace, well, try to figure a proper default for that, because the other one requires 2 gigs and another one requires 10 megs or something. But at least it's a some default. And in case of Kubernetes and in a case of pods, a some default is better than nothing. So, sort of putting this all this together, the crucial thing is really secure your cluster kernel. Make sure you understand how authentication actually works and how to configure it properly. If you're running on Google or Amazon, well, tough luck. You don't have the controls to configure authentication or many other things on the control plane. Make sure you understand how role-based access control works. There's no way not using it. Well, you can actually disable role-based access control, but that's just a stupid idea. Don't do it. Unless you're just testing something locally. And make sure all the components are secured, because there's a lot of system-level components which by default might have not so secure configuration. And namespace is for the win. So ensure that your namespace actually has all these things configured. It has quotas. It has pod security policies configured properly. In every namespace, there's a default service account being used. So ensure that those default service accounts are actually tied into a sensible pod security policy. We actually didn't talk about network policies. Those are also a thing which is scoped into a namespace. So make sure that each and every namespace does have a sensible network policy in place. And also these limit ranges, and there's a bunch of other things to make sure you have in every single namespace. If you're actually running or maintaining your own Kubernetes clusters, you can go and customize it. So these admission controllers that I've been mentioning, like for these pod security policies and whatnot, you can write your own custom admission controller. It's actually doable through webhook, which you can implement in a way where you can actually force things the way you like them to be forced. It's not trivial, but it's not rocket science either. So at least take a look on whether it makes sense for you or not. And then there's this new-ish fancy operator SDK thing, which with you can actually easily write custom operators running within the cluster, which can then react when you, for example, when you create a namespace, this sort of a custom operator can react to that and actually go and configure that namespace properly for you. I've been sort of thinking of writing that sort of an operator for a few months already, but never had the time to do it actually. But that would be super nice. Whenever somebody just creates a namespace, a custom operator somewhere goes and configures it to be secure. That would be nice. So if anybody goes and writes that, ping me, I'll help. Thanks. I think there's some room for questions also. Thank you.